Okay, where we're going to head in this short video is we're going to look at eccentric muscle actions, how eccentric training might change muscle morphology, and we're going to talk about the neural control of eccentric muscle actions as well. So let's first start off with what is an eccentric muscle action. Well, if we think about, standing in a cage like the picture on the far left where you're holding a barbell without moving, we'd understand this as an eccentric movement or an eccentric muscle action. Remember, at the muscle level, even though there's no external work being done, the muscle might be doing some work on the tendon, actually shortening a little bit, but let's just say for the sake of the argument, that's an isometric muscle action. The video in the middle is a concentric muscle action or a concentric movement where the athlete or the individual is lifting up a barbell, right? So positive work is being done. And then the video on the far right would be representative of an eccentric muscle action where the muscles are lengthening under tension. And what I can tell you is that eccentric muscle actions, we've known forever that they are a highly potent training stimulus, and they've been a massive puzzle to scientists who are trying to study how muscles work. In fact, here's a quote from Andrew Huxley on his Reflections on Muscle from 1980. He was the father of the cross-bridge theory, the mathematical model for how muscles contract. And he said, "I imagine that special features have been evolved which allow this elongation of muscle to take place without damaging the muscle. And I suspect that many of the unexplained phenomena associated with muscle lengthening are related to these special features that have little relation to the processes that take place during shortening." It's the idea that shortening muscle actions and lengthening muscle actions are divergent. And that's why this part of the course is so important, because we need to understand how to assess eccentric movement abilities and eccentric strength capacities in our athletes. It's important for performance. It's very important after injury. And together, we need to understand a little bit of the science that underpins this so that we can actually navigate our way through this very complex part of the training world. So you have to start by looking at the force-velocity relationship to really understand eccentric muscle actions. And if we look at the force-velocity relationship on the screen is the Hill relationship. Let me draw that out. We've got force and velocity, and we know this sort of hyperbolic relationship between force and velocity. As the velocity of the muscle action goes up, the force goes down in this concentric region of the curve. But then when we look at the muscle eccentrically, what we observe is that muscles can generate substantially more force eccentrically than they can concentrically. Very interesting to note that studies that have looked at eccentric exercise and in animal models, this increase in force is actually associated with lower EMG and actually lower energy consumption. So meaning that it's actually more efficient to be using eccentric muscle actions than concentric muscle actions. And, we have less muscle activity, probably owing due to the fact that we have passive structures that are engaging to be able to sort of create some, force in and of themselves, consequent to the stretching of these contractile and these structural proteins. So this is the most notable thing about looking at eccentric muscle actions. But here's the challenge. If we were to actually look at this in a human, imagine you're going to now measure this in a human, the reality is that we do not see this. This is not what happens. In fact, if we were to measure this in a human who's untrained, we might actually see something like this. Not only would there be sort of a downshift of the concentric region of the force-velocity relationship, but our capacity to make force eccentrically is nowhere without a little bit of training. This is why we need resistance exercise, and we need to understand the role of eccentric training in the overall training process. So under voluntary control, it is simply not possible for us to access this full potential of our muscle. So we need to ask some questions as to why this is. Because in vivo, you're not seeing this type of effect. However, if you engage in resistance training exercise, the right type of resistance training exercise, the possibility exists with athletes that you actually see them start to increase that eccentric strength capacity closer to what we know the muscle is capable of doing. And this is just a sign of some of the potency here of eccentric training methods, heavy resistance training in general, but also the trainability of this. All right, let's talk a little bit about how eccentric training might be of benefit for our muscle morphology. And you may remember talking about the cross-sectional area of a muscle, so hypertrophy, we increase the physiological cross-sectional area. Force is proportional to the physiological cross-sectional area, and by increasing the force-generating capability of a muscle, by making more contractile proteins in parallel, right? This is one of our basic tenets of why we engage in hypertrophy training. However, what about making a fascicle longer or a fiber longer, putting more sarcomeres in series? This is called sarcomerogenesis, and sarcomerogenesis is the idea of adding sarcomeres in series and basically elongating a muscle fiber, which we can measure in vivo by using ultrasonography, looking at the fascicle length. Now, what would this do for us? Well, I mean, first of all, let's start looking at some of these short-term studies, because this is where eccentric training becomes particularly interesting. The jury is out as to whether or not eccentric training offers a benefit above and beyond traditional resistance training exercise, where you're using a combination of eccentric and concentric movements. We still don't know yet for sure, but what we do know from some short-term training studies is that it seems like heavy eccentric training and accentuated eccentric training does provide some additional benefits above your traditional form of lifting. And in fact, there's numerous papers that suggest that one of the benefits is the possible that heavy eccentric training can actually increase fascicle length in humans, and certainly this has been shown in animal models. So why would we care about this? Well, fundamentally, you think about sport performance, and you think about hypertrophy, improving the capacity to make force at the force end of the continuum, but we know that many sports need to have the ability to make force at high shortening velocities. And this is where this idea of sarcomerogenesis, or increasing fascicle length, becomes really interesting. In theory, if we increase fascicle length, we should be able to increase the velocity of shortening. And you can think about all the various scenarios where this might be of interest. And we'll actually talk about the role of accentuated eccentric training for accomplishing this very goal. As we wind down this short presentation on eccentric training and eccentric muscle actions, we have to talk about neural control of eccentric muscle actions, because the neural control of eccentric muscle actions is very, very different than what we see when a muscle is shortening. There are some distinct differences, and we've already seen one of them. It's that during eccentric muscle actions, there is actually a lower level of EMG, despite the fact that there is increased force that we measure. So that's the first interesting thing. But you think about a human engaging in eccentric exercise, heavy eccentric movements, and the reality is we cannot tap into our full potential. And so what we see using surface EMG, surface electromyography, and also a twitch interpolation technique where we use electrical stimulation, is evidence of reductions in motor unit rate coding. So the discharge rate of motor units appears to be impaired in untrained individuals when it comes to these eccentric muscle actions. So we can't access the full potential. And we can find more evidence of this actually using electrical stimulation. This is an example of an electrical stimulation technique. Here what's happening is we're using an electrical stimulation of the femoral nerve to activate the quadriceps muscle maximally. And we can do this in order to evaluate the excitability of muscle, and we can also look at the excitability of spinal motor neurons. And the way we can do this is by looking at something called the H reflex. When we give this electrical stimulation, what happens is the alpha motor neuron depolarizes, but we also get a signal that runs back up the primary ending of the muscle spindles. It's called the H reflex, and basically we register kind of the electrical equivalent of a stretch reflex. And this gives us an indication of how excitable those spinal motor neurons are. And so using this type of work, we can actually evaluate what happens with neuromuscular control in eccentric versus concentric muscle actions. And the key thing is, despite the fact that we have more force, EMG is lower, and in an untrained state, we actually don't see an increase in force in eccentric muscle actions. We need training to get to that point. And further, what we can see is that the discharge rate of our motor units is lower in eccentric muscle actions without training. And this is further supported by data that shows that during eccentric muscle actions, the H reflex is also suppressed. It's smaller, meaning that spinal motor neurons are less excitable. Altogether, what we know is that if we can engage in resistance exercise, heavy resistance exercise, and particularly heavy eccentric training, we can actually see that we can reverse some of this, let's just call it inhibition, that's in the system. We get greater central nervous system drive down descending pathways, increased spinal motor neuron excitability, and altogether increased EMG, which is telling us that our muscles have higher levels of activity, right? And hopefully the capacity to generate more force. But where we actually see the evidence of the performance side is in this upward shift of the force-velocity relationship, which indicates to us that a real performance change has happened. All right, this is our first video looking at eccentric muscle actions. We talked about them in general, what they are. They've been a puzzle to scientists for sure. The behavior of muscle isn't the same eccentrically as it is concentrically. We can see that there's profound effects of eccentric training potentially on morphology, thinking about increasing fascicle length, but really where we wanted to spend some time was looking at the neural control of eccentric force, and what we know is that humans are unable to access their full potential, and we need heavy resistance training and potentially eccentric training to get there.